So this is problem number 4 of diesel cycle. So we're given with an air standard diesel cycle. So the compression ratio is 16. So this one is our R. The cylinder bore is 200 mm. So this is our D. Then we have the stroke, which is L. The compression begins at 1 bar. So this one is our P1. This one is our T1. The cutoff takes place at 8% of the stroke. So this is the same as what we did for sample problem number 3. So this is 8% of the stroke. Determine the pressure and temperature at the salient points. The cutoff ratio, RC. The work done per cycle, work net. Air standard efficiency. And the mean effective pressure method. So in finding that temperature at the salient points, so we need to solve for P1 to T4, then P1 to P4. So for T1 that is given, all we have to do is to convert 27 degrees Celsius to Kelvin. For T2, we use the relationship, isentropic relationship between T2 and T1. Since we already have R that is 16, we just substitute the value, so that's we have 909.9 Kelvin. For T3, we can solve T3 when we have RC and T1. We already have T1, so we need to solve for the cutoff ratio, RC. From previous computation, we learned that the relationship between RC as well as R and the percentage wherein the cutoff take place is given as 1 plus 1.08 16 minus 1. That's why we have RC as 2.2. It's the same as what we did in sample problem number 3 when we'll derive the equation and finding for RC. So RC is 1 plus the percent, 8%, 0.08, the ratio 16 minus 1. So that's why we have 2.2. So substituting, so we have T3, 2001.75 Kelvin. And T4 in terms of RC and T1 is also given. So we have 905.16 Kelvin. For P1, that is already given 1 bar, or that is 100 kPa. For P2, the same relationship, isentropic relationship, that's why we have 48.5 bar. Since this is a diesel cycle, heat addition happened at constant pressure. P3 is equals to P2. This is a constant pressure process, so they are the same. For P4, so we use this relationship that we derived, P3 RC to the power of K over R to the power of K. So that's why we have 3.01 bar. So one way of checking is the maximum temperature should be at T3 and the maximum pressure should be at T3 and T2. Lowest at 0.1. So that's correct. For the network, so we use the equation MCP Q in minus Q out. So we need to solve first for the mass. So the mass using P1, V1, and T1. So for P1, that is 100 kPa, just convert 1 bar to kPa. For V1, that is the swept plus the clearance. For the swept, that is pi over 4 d squared L. So substituting, just convert it to meter cube. So for VC, the relationship is given as Vs over R minus 1. So to solve for the clearance volume, that is the swept, divided by R minus 1. Since we already have the swept volume, and then we already have R, we just substitute the value. So that's why we have our value for V clearance is 6.283 times 10 to negative 4. So that's why we have V1 is V S plus V clearance, so that's 0.01005 meter cube. So substituting the values to the equation for mass, which is 0.01166 kilogram. And thus for network, so we have mass CP, which is 1.005, T3 minus T2 minus mass, then CV, this is the rejection part. 905.16 T4 minus T1. That's why net work is 7.74 kilojoules. For the mean effective pressure, so we just use the same formula, work over V swept. So these are already given. We already solved this. So that's 8.21 bar. We just convert kPa to bar, divided by 100, so we have 8.21 bar. So that's it for diesel cycle.